Learning targets today. Let's see what we're going to learn today. I can find the limit by substitution even if the denominator is 0. Because we all know that's a special no-no when the 0 ends up in the bottom place. On the bottom of a fraction. Anyway. I can identify if a limit does not exist graphically. Okay. I can find one or two-sided limits graphically. So, we're going to take a look at some pictures today. All right? I got them from my trip to Seattle Island. It's a slideshow. I'm just going to show you pictures today. Thank you. Thank you. Thank you. All right. So, let's take a look at this. And we're going to find the limits by substitution. All right? Now, do not do any work. I want you to tell me what to do without writing anything down. What happens if I solve this by substitution? I put a 2 in. Okay, yeah, I get 2 squared minus 3 times 2 plus 2, which is fine. That's 4 minus 6 plus 2. Okay, well, what's that, 0? I'm going to talk about the top right now. 4 minus 0. Okay, which is fine. We're going to 0 on the top. But what happens when we take 2 squared and subtract 4? I get a 0 on the bottom. Okay? I get a 0 on the bottom. So you guys just be like, undefined, must not have it. But you must check for something first. If you put a number into a fraction and it causes the denominator to be 0, okay, you need to look for something first. What do you think I might be able to do? Factor, and then that's how it's solving. T-bone. Look at you. No, okay. What is a what's the factoring of the top? How does the top factor? Stop it. No, I don't take out nothing. I do what? It's a quadratic. What do I factor it into? Booty cheeks. Boom. Boom, boom, boom. Okay, so I know there's t's here, right? Yeah, I need to find two numbers that multiply to be -2 that add to -3. That is -2 and -1. So I am now taking the limit as x approaches 2 of t minus 2 and t minus 1. Yes, please start writing this down. Thank you for reminding me. What about the bottom? It is a perfect square, so what does that factor out to be? Yes, yes, I got you. T minus 2 and t plus 2. So if I do this here, yeah, man. Okay, so I do this, and look, if I still plug my x in, if I still plug my, wow, isn't that weird if I use t's here and x there? I should probably change that to a t. Yeah. I should probably change that to a t. Yeah. Wow, that was a candy waiting to happen right there. If I still plug a 2 in for t, here I still get 0 on the bottom. And if I multiply anything by 0, the bottom is still 0 and it's undefined. But what can I do now? The top and bottom cancel. You have a t minus 2 and a t minus 2. Factoring and canceling, when you first learn it in 8th grade, you need to be good at that and stay good at that for the rest of your high school careers and into college, depending on what math classes you take. So now, can I throw a 2 in for my t here? I can. I get 2 minus 1 over 2 plus 2, don't I? Yeah. Which is? 1 over 4. Good job, buddy. And there you go. And there you go. Oh, God. So why does that happen? That's weird. If I put a 2 in, it doesn't work. But if I manipulate it, it does work. That's a little cray-cray, isn't it? It is. So why don't you guys try 1 on your own? Obviously, I can't throw a 0 into the bottom. It would end up 0 minus 0, which is 0. So why don't you guys take a couple minutes, see if you guys can figure that one out. So let's go over the work. I heard -1/2 from a lot of people. Let's see if that works. So obviously, we need to factor and cancel here because 0 will not work in the bottom. I will end up with 0 minus 0. Dario, what can I factor out of the top? X squared. And that would leave me with what?
5x plus 6.
You got it. And how about Adrian? What can I factor out of the bottom? X squared. And what does that leave me with? Okay, now if we are factoring simply for the purpose of canceling out, because you still can't put a 0 in for either one of these x's, because then anything times 0 is 0. So if we are factoring, trying to cancel something out, yeah, you should have something the same on the top and bottom, and you do now. So now I can throw a 0 in here, and I can throw a 0 in for here. So it's 0 plus 8 over 0 minus 16, which is 8 over what, Eamon? -16, which reduces to -1/2. That is absolutely correct. Good to go. I'm proud of y'all. I am. So let's take a look at some limits graphically. All right. First of all, we have one-sided limits, and we have two-sided limits. And they're not complicated. They are just that, approaching the limit from one side instead of both. If I have something like this notation, we should be getting familiar with this. And you approach some value, but it has a little plus in the top right, that means I'm taking the limit of x as we approach that x value from the right side. That little plus means I don't care about both sides. I'm just looking what y value as I approach from the right. What is it going to hit? I don't care about the left, just the right. So what do you think is going to happen if there's a little minus? Yeah, I don't know if you can see it. There's a little minus there. Yeah, that would be the limit as you approach that value of x from the left side. Okay. And last but certainly not least, both sides here. Because this is what we normally do. This is how we find a limit. Okay? If the limit from the right side is equal to the limit from the left side, then it has a limit. Okay? That's what, when there's no plus or minus here, that's pretty much what we're saying. That's a two-sided limit. All right? Yeah, well, it'll ask left side or right side, or they'll give you the notation with a plus or minus there. That's like, you know, I'm looking at this from the right. And think about it, because all your x's are positive on the right-hand side. All your x's are negative on the left. So if it's negative, it's going to be coming from that side, the left side. If it's positive, it's going to be coming from the right side with the positive. All right, you guys should be familiar with this. This is that int x, that step graph we talked about earlier. Let's take a look at something. What? I should have one of you guys read. How is this read? How do you read this notation right here? We want the limits of the function int x as x approaches 3 from the right side. This is a plus there. I don't care about as it approaches 3 from the left side. I just care from the right side. See, there's a little plus here. It's on your notes. You can see it a little bit better. That means as I approach x, which is 3 right here, this line, as I approach it from the right, not the left, as I approach 3 from the right, here's the graph right there, isn't it?
Yeah.
Which y value is it approaching? It is approaching 3. All right? Now, let's take a look as we approach the same line from the left side. It looks like it's approaching here. Isn't this where the graph is? It would approach the y value of 2. Right. So who can tell me what the next one is? What is just the limit of 3? Not from the right or the left, but from both the right and the left. It approaches y equals 0. It approaches y equals 1. As I approach 3, this line, as I approach it from the right side of the graph, and the left side of the graph, well, it should approach one value. Does it approach one value? No. So guess what we say? There is no limit. It's undefined. You can do this, or you can write undefined, or you can say, I guess, no limits, or whatever. But in order to have this work, this number from the left and this number from the right, it needs to be the same thing. You need to put the same number. Why that? Otherwise, you don't get away. Rescue. Okay, so who can tell me? Who can tell me now? Who can tell me now what is my limit of the in function x as x approaches 2 from the left side? So here's 2. Okay, it's going to approach this x value. I'm approaching it from the left side. Which number is it? 1. As I approach this way, it's at this y value, isn't it? At that height of 1. Are you ready for this? Y'all ready for this? Everybody's going to get this wrong yet? No, you won't. 2.01. Where is that on the x-axis?
Right there.
It is a scoot after the number 2. So let's say that is right here. That is 2.01. It's probably a lot closer. Which means it wouldn't be directly over 2. It'd be like, sorry, it curved. It's right here, technically, on this line. It's not right at 2. This is right at 2, that dot. But it's just after that. So is there a limit? Does that approach the same y value from both sides?
There is no limit.
Yeah, it's on this line. So technically it goes this way, and it goes a little bit that way, doesn't it? It goes a little bit that way and goes a little bit that way. So what does it approach? Which y value? 2. Let me make it a little bit more obvious. I made it 2.01 on purpose. What if it was 2.5, which is right here? Then wouldn't that be right here? See on the line, you got to go this way in the line, and you got to go this way in the line? It would be 2. But I made it just a hair after 2.01, so you don't really see a lot of the line, but you got to move a little. You got to move actually 0.01 on that line to get to it. Crazy, right? I think so. All right. You guys are doing good. Let's see. Yeah, I'll give you a few minutes. Or do you guys want to go over this together? Together. For the sake of time, we'll do together. This is the graph of x cubed minus 1 over x minus 2. You can see it goes like this, and then it shoots down like that. We'll put arrowheads here, you should. And then it goes up forever that way, and then comes in like that. All right? So what is the limit as I approach the number 2 from the right side? As I approach the number 2, here's my x value of 2. What does that look like? What's that called? My favorite math word in the entire world. Who's that? An asymptote, right? That'll go up forever, but closer and closer to it not touch. So if it goes up forever, it goes toward infinity in the positive direction, up. It won't ever reach a number, just go up forever. I can look at the table, as my x value gets closer and closer to 2 from the right side, my y value just goes higher. What about as I approach 2 from the left side? As I'm approaching it from the left side, this way on the graph. It goes down forever. Do you understand that? It goes up, it's an arrowhead, it goes up forever. Arrowhead goes down forever. So, if I ask you for the limit at 2, and I look at the limit from the right side, and I look at the limit from the left side, are they the same value? Are they the same value, though? No. So does the limit exist? No, it does not exist. No, it does not. It has to approach the same value for it to exist. For it to have a value, from the left and right side. And you'll have practice on this little homework, and then we'll go over it, whatever the case might be. I think we have one more thing to do here. And I want you to use your calculators for this one. If you all have your calculators. Okay. I thought you were going to just use like I. Yeah, you said I. I. All right. I want you to graph I. I want you to graph the function x squared times the sine of 1 over x. And I want you to graph it in a 10 by 10 window. So I'm going to go view, that's it. I'm going to go right here, and I'm going to do this. And I'm going to say y equals x squared times the sine of 1 over x. Okay? Right here. And if I graph it on a 10 by 10 window, it doesn't look like anything crazy, does it? Look what I have on your notes, though. It doesn't look like that kind of spider webbish thing. All right, well, let's change our window. Let's go from -1 to +1. I'm looking at this right here. For the x-axis, and -1 to +1 on the y-axis. So I'm going to go to my window. -1 to 1. -1 to 1. So I'm essentially zooming in by 10 times as much. So let's graph that. Okay, now look. Oh, it looks like it hits that, does something. Oh, see, it looks like a little curvish there. We still can't tell. Let's zoom in even further. From -0.2 to 0.2 on the x's. And on the y's, be careful. I want -0.02 to +0.02. Okay. So I'm going to go back to my window, go with -0.2 to 0.2, and then -0.02 to 0.02. And when I graph that, oh, look at that. That's crazy, isn't it? But what's one thing you notice between what I graphed and what's on the paper? Look at the one difference. Yeah, the curves on the top. You see how this and this are not on the graph? Let me explain something, children. There's a theorem. If a function is sandwiched between two other functions, the sandwiched functions limit is the same as the border functions. Okay? I say, just look at your table with x values extremely close to the limit. Meaning, I want to look at my x values that get really, really close to when x is 0. I want to look at my values, okay? I want to look at what y value that approaches. Okay, just look at your table with your x values extremely, extremely close to the x value in the limit. The x value in the limit is 0. So I want to look at all my x values that get really, really close there. I don't want to look at 0, 1, 2. You don't want to go off by like 0.01, 0.001. It's crazy. In my graph, if I draw this line here, that looks like this looks like it might be x squared with a parabola, right? And if I draw the bottom functions, these are the border functions. If I draw this, that looks like maybe a negative x squared, right? It's just x squared flipped. So it's saying this whole mess right here, the limit as that gets closer to 0 will be the same thing as the red and green line get closer to 0. So what is it, when the green line gets closer to 0, what does it approach from both sides on the y? 0. The origin, right? What about this sandwich file? What does that approach? 0. So if those both approach 0, this blue one is going to approach 0. It's going to approach 0. So let's do this. This should equal 0. I can't throw a 0 in here because that will become undefined. So I can't do it that way. So let's look at my table. If I look at my table right now, let's close this, view the dash LCD, it's all nice and clean. Let's look at my table. Bang. And 0 gives me an error, right? Because it doesn't exist at 0. 1 over x, it's the same. So let's change our table set to 0.001. So instead of changing by 1, it's going to change by point. It's going to give me 1.001, 1.002. And I'm going to start at 0. Let's look at our tape. Yep.
Here.
Start at 0. So I got to make it 1. And that's going to have to go 1,000. So let me go 0.01. Okay. See this number get closer and closer to 0. Oh, it starts at 0.0. You guys, I want to start at 0 and I want to move by 0.001. That was my mistake. I switched my values. Yeah, and it would help if I put a 0 then a 1. Here's where I get an error. Okay? Look, do you know what that E means with the -4? That means it's -1, but the decimal's over 4 space. 1, 2, 3, 4. So it's 0.000. What about when I get closer to... This moves over 7 times, so it's 1, 2, 3, 4, 5, 6, 7, -8. It gets closer and closer and closer to 0. There you go, children. Homework, do it. Love you.